Hello everyone. In today's session, we will discuss a tree data structure question that is same tree. Okay, let's understand the question. Given the roots of two binary trees P and Q, write a function to check if they are same or not. Okay, so how we can tell either two binary trees are same or not? So the two binary trees are considered the same if they're structurally identical and the nodes have the same value. Okay, if you consider this example, right, we have P is the first tree, Q is the second tree. Okay, so what is the root node? 1. What is the root node here? 1. No, what is the left subtree of 1? That is 2. Here also 2. What is the right node of 1? That is 3. What is the right node of here? 3. So both are same. So we have to return true. So consider one more example. Here the first tree is 1, 2. Right tree also 1, 2. But root node is matching 1 and 1. But what is the left node of 1? That is 2. But what is the left node of 1 here? Null is there. Correct? So we have to return false. It's not matching. Correct? So let's solve this problem. Let me take the same example 1, 2, 3, 1, 2, 3, right? So let's take two trees 1, 2, 3. So that is the first P 1, 2, 3. So we have one more Q, right? 1, 2, 3. Let's construct the tree. 1 is the root node, 2 is left subtree, here 3 is right subtree. For Q also 1 is the root node, 2 is left subtree, 3 is right subtree. Correct? For 2, are there any for elements? No, right? So let's make null. N means null. Here also null. Null. Got it? So now the approach is, first we have to consider here root node, right? First we have to recursively check both the trees, left subtrees and right subtrees. Okay, wherever we found mismatch, just return false. First one, right? For 1, what is the left subtree? 2. Okay, so for 1, what for the second tree, what is the left subtree? 2. Yes, matching. Again for 2, what is the left subtree? Null. For here also, what is the left subtree? Null. Whenever we found both having null, return true. Now for this, come to right. Here, what is the value? Null. Here also null. So return true. Come back. So now, so from here to 2, for this 2, right? Everything is matching for 2. Now move to the right subtree. That is 3. For both the trees, we have to check the right subtree. That is 3, 3 matching. For these 3, what is the left? Null. Here also null matching. For these 3, what is the right subtree? Null. Here also null. Okay, both are matching. Correct. So we have to return finally true. Everything is matching. So basically, we have to check here 3 conditions. First condition is if, okay, the first P is equals to null and Q is equals to null, return true. That is the first check. Second check is P is equals to null or not and, okay, or Q is equals to null, okay, return false. Why? So if here, assume that here we have a value and here we have a null, which means these both are not identical, right? So we have to return false. If both are null, means they are identical, return true. If anyone are opposite, return false. If any one is null, return false. Third check is we have to check the values. That is p dot value not equals to q dot value. If suppose here different values are right, that time also we have to return false. Correct? Then we have to just recursively call the left subtree and right subtree. That's all. Left equals to, here assume that we have on some function we will be having, right? Check the same tree or some function we will be calling definition. Here we will be passing p and q or nodes. So we have to call. So this is kind of one function. Same tree. P dot left, comma q dot left. Same way we have to call right. Same tree. P dot right, comma q dot right. Okay. Finally, we have to return left and right. So if both are true, then return true. That's all. So this is our pseudocode. Got it? So let's submit this problem in LeetCode. If and p is null and q is null. If both are null, return true. Correct? If any one is null or q is null or not and so return false. Check the values. If p dot value not equals to q dot value, both are not matching also, false. Right? Now recursively call the left subtree is same tree of p dot left, comma q dot left. Same way, right. Same tree. We have to call right, comma q dot right. So finally return left, now right. Okay, both are true, then only return true. Let's run the test cases. Accept. Let's submit this problem. Yeah, it's accepted. Okay, so what is the time and space complexity? So the time complexity is order of n, because we are traversing all the nodes in the tree, both the trees, both the binary trees. And the space complexity is order of n, because we are calling a recursive function for storing all the stack. So all the nodes will be using stack. So space complexity is order of n. Thanks for watching this video.